Hello, guys. Thanks so much for taking time to join our AI Day Summit today. We're back after a short 5-minute intermission, and and lucky today we have an amazing kind of speaker here with us, John.
Hello, happy to be here. Hey Nathan, how are you?
Doing very well. Doing very well. Are you calling out of New York, SF today?
I'm in SF. I would have loved to be there in person with you all in New York. I'm normally in New York, but in SF today before heading back later this week.
Amazing, amazing. That's very cool to see. So, John, I guess for some context, is part of the Arise team. He's in charge of a lot of the DevRel related stuff there, and they built an amazing interpretability platform when it comes to AI that we're kind of actually trying to use for our multi-agent AI system. I'll let John from Arise take it away.
Yeah, awesome. I have a little bit to share with you guys today. As Nathan mentioned, we're a interpretability observability platform at Arise. And so I'm going to show you guys a little bit of that. I'm also going to go through some slides that kind of talk about how we approach evaluating and measuring the performance of agents or multi-agent systems as well. So we'll go through that with you guys. I'm going to see if I can share my screen here. All right. And I think you guys can all see my slides. Let me know if you guys can't see those. But yeah, as mentioned, we'll go through a little bit of evaluating AI agents and assistants. The tool I'm going to demo for you guys today as we go a little bit further into the process here.
John, I can see it, but for some reason the slides are like really small.
Oh, weird.
My view. Maybe try unsharing and resharing.
Hold on. Let me just do this really quick. I'll try resharing here. I don't know if anyone uses Arc browser, but I think it, man, of course. Okay. I think it's screwing me up here. So let me do this. All right. I'll be back in 10 seconds. I think I can fix this. Hold on. All right. Is that better?
Yeah, that's perfect. You're all good. Yeah.
Okay, awesome. So yeah, we're going to be using Arise Phoenix, which is our open source tool. So Arise Phoenix allows you to do LLM tracing, evaluation, experimentation. It's totally open source. It's self-hostable, and it's completely, you can run it locally on your own machine, whatever you want to do there. And if you like observability, if you like these open source tools, please do consider giving us a star on GitHub, because that's our only way of knowing the popularity of the tool, that and downloads. So please, if you like the tool, give us a star there. Awesome. I don't really need to go into too much detail about how important agents are and how much they have been a big part of last year and then this year. I think everyone on the call knows that, as we've seen some of these tooling and some of these tool calling capabilities be incorporated into models. So I'll skip past that and kind of dive into the meat of what we're going to talk through today. So before going into evaluating agents and how we approach evaluating them, one thing that's kind of helpful is just to do a little bit of level setting about how we think about an agent. And we typically think about three main components inside of the agent. So we think about a router, some sort of skills or execution branches, and then memory. And so I'll talk through each of those really quickly. The router, when we think about it in the context of agents, is typically that piece that determines which skill or which kind of path to follow inside of your agent based on whatever user query or previous steps have been completed. And so that could be LLM with function calling, which is one of the main ways we see people setting this up. Could be a simple NLP classifier. Could even be like rules-based code. Get into a little bit of definitions about what an agent is at that point, but we'll table that for later. And so routers are something that's used by lots of agents. It's not used by all agents. Some frameworks in particular kind of distribute the router logic as opposed to having it in one centralized location, but they still have some amount of deciding which step to take or which next step to follow. So we think about the router as one unit. We think about the skills and branches as the next. And so these are basically the capabilities of the agent. So things like it might have a RAG skill to be able to evaluate or to kind of complete a RAG pipeline there that it can use as a skill. It might have an external API that it could call. It could have other LLM calls, API calls, or application code that make up these capabilities of the agent. And so each of those agents has to have at least one of these. If you don't have any skills, then the agent can't really do anything. So you got to have at least one skill that you can complete. And then the final piece is memory. And so memory is something that is basically a shared state that can be accessed by all the skills as well as the router of the agent, kind of retains information as the agent executes. And the most common thing we see people storing in that memory is some sort of kind of messages object, especially when you're building an initial agent. That usually looks like the previous LLM calls or router calls, any tool responses, anything like that, to kind of be a log of what the agent has done so far. And actually, some LLMs, if you're using them for routing, they rely on this sort of structure to know what's been done so far. So those are kind of the different pieces we see. Just to put it to a specific example here, a kind of common example we see is some sort of chatbot on a website. And so oftentimes you'll have things like chatbots that can take in user questions that might then route to one of a few different skills, either a purchase skill or more like a kind of maybe a deal lookup skill. You might have skills for kind of customer service responses or something like that as well too. But your router would choose one of those to go to, would call that skill, and then often return back to the router and kind of continue looping through that experience of going from a router to a skill and back and forth. So that's all well and good. The tricky thing is, even if you build your agent, even if you can kind of get it working initially, it's very hard to get it to perform at a high level and at a consistent quality. I think a big part of that is that LLMs themselves are non-deterministic, so steps of your agent will be non-deterministic. And then if you have a mistake that happens high upstream in your agent, that can come to some very strange responses downstream as that kind of filters through the different steps of your agent. And then even if you get your agent to work correctly and kind of give the responses you expect, it might still be taking inefficient paths before getting to the right solution. So it might call extra tools it doesn't need to, it might enter into a loop for a while before breaking out of it. And so all of these give you reasons why it's kind of hard to build an agent that works consistently. And while frameworks are extremely helpful to make building easier, it can sometimes make debugging harder depending on how familiar you are with the framework. So all of these are sort of reasons why it's important to have some sort of evaluation technique in place. Switching gears to talk a little bit about the evaluation side of things. This is where you can kind of pick your different pieces of the agent and you can examine how you would evaluate each of those different pieces to evaluate the agent as a whole. So the router is one piece of that. The skills and functions are another. You could evaluate the memory in some capacity if you wanted to. I think we don't often see that, but you technically could. And then the third one that we see more commonly is the path, the overall path that the agent took itself. So when it comes to the router, we often see that evaluated on a few different axes. One is just, does the right choice get made? Does the agent pick the right skill to call? If it's that chatbot agent, is it choosing the customer service skill correctly? Is it choosing the product lookup skill correctly there? And then once it's chosen the right skill to call, does it extract the right parameters from the user's question? So this is where you'd have to pull in, say you had a question that was, chatbot, can you help me check the status of my order number 1234. You have to, your router has to specifically choose to call the order lookup skill that it would have. And then it also has to extract out that order number 1234, has to know it's an order number, and has to properly fill in the function based on that information. So parameter extraction is another area where routers can fail there. Technically speaking, there's a third, which is function generation. So once it's chosen the right parameters, does it actually generate the right function calling code? In practice, we almost never see large enough models fail at this task of function generation. It's usually more parameter extraction or skill choice that can be the failure point there. So mentioning it here, but it's typically that function generation is typically not one that we see as a big problem area. So that's your router. Then when it comes to evaluating your skills, this is where you have a few different options, and you can rely on standard LLM or code-based evals. It's funny saying standard LLM evals, it's still kind of an evolving field, but there is some amount of standardization that we do see around how you evaluate different common LLM operations. So for things like RAG skills, a lot of times this is evaluating the retrieval step or the correctness of the response, evaluating whether there's any hallucinations in the response or things like that. For code gen, it's usually more like, is the code readable? Is it correct? Does it run? And then for API skills or for sort of less LLM focused skills, then you might just have typical integration tests or unit tests. So for those, you could actually do more of a code-based approach as opposed to having to rely on an LLM evaluation. So for kind of the first two chunks here, we often rely on an LLM as a judge or an LLM judge to make the distinction of whether a response was relevant or correct or hallucinated. But you can combine those with more traditional kind of code-based integration tests and unit tests. And one piece of our platform is the LLM as a judge code. We have a library of different prompts that can be used there, and I'll show you guys some of that as we go on. And then for all of your skills, whether they're API-based, more code-based kind of tests, or LLM-based kind of tests, you can always compare against ground truth data. And so if you have a golden data set that you can compare against, or if you can put one together, you can always use your comparison against that golden data set as an evaluation benchmark. And I won't go into it too much here, but I'm happy to dive into it further for anyone who's curious. But we typically kind of see this pattern where people will use that comparison against ground truth data for their development, and they'll kind of use that as a benchmark to see how the application is performing. And then they'll launch into production, and then they'll run some of these other evaluations on production data to kind of scale up evaluation much more and monitor the performance of their application, and then work some of what they see and what they find back into the experimentation phase and the development phase, and sort of move between those two. So oftentimes we see comparison against ground truth in more of the development side of things, and the other evals that we see here in more of the kind of production data side of things, but they do overlap as well too. And then finally, when it comes to the path, or this idea of convergence, or is your agent converging on the optimal path to go through for a type of query, the easiest way to actually check for this, and the way that everyone should start checking for this, is just look at your data and just look to see what kind of paths your agent is taking. That's sort of step zero, where when you are developing and building things out, you do want to actually examine the data that you're collecting, examine traces, which we'll look at in a second, to see what your agent's doing. It's almost like the vibe check in a way, but it is a step that people skip sometimes, and it is a really critical one as you're developing. Obviously, you can't do that as you scale into production, so tests like checking for convergence here is a useful way to kind of scale up that process. And so the idea here is there's a bunch of ways to measure convergence. One that we do often is we will run an agent on a similar set of queries. So taking the Kindle example from a previous slide where users asked about deals on a Kindle, you would run your agent on that same question phrased a bunch of different ways, or many, many different ways, kind of questions where your agent should really take the same path through it, but you just phrase it in different ways to actually try to get it to trigger different paths or other behaviors. Then record the number of steps taken for each of those different runs. And you can calculate a numeric score based on that by essentially comparing the number of steps taken by each run to the minimum or number of steps or the optimal path that your agent took. And that gives you a representation of, hey, what % of the time is my agent taking its minimum length path to get to a result? And so it gives you a way to kind of measure convergence at a more scalable way. So those are all three different kind of areas of an agent that you can evaluate. You can use different techniques to do that. I'm going to use the remainder of my time here. I have a few more minutes, and I'm going to actually show you guys a quick demo of what some of this looks like in the platform. And so I mentioned, again, open source tool that we have called Arise Phoenix that I've used to trace this particular agent. So in this case, I have set this up connected to an agent that allows me to talk to a local database. And so I can ask it to do things like, in this example here, create a bar chart showing total sales by store. I have a local database of sales data. I'm using this agent to either create bar charts from it, or create different kinds of charting, or just ask questions about the data. And so this is one particular run of the agent. And so what I can see going through this is I can actually follow all of the different calls that are made as my agent's executing. So I can look at the initial router call here and see, okay, in this first step, this is my router. It's choosing to call this lookup sales data function that I've given it. I could actually look in the tools as well too and see all the functions that were available to it. So in this case, I have a lookup sales data function. I have a analyze sales data function, and I have a generate visualization function. And so in this case, my agent chose to call lookup sales data function to gather data and answer the question. I could follow it through as it executes that tool. That particular tool itself actually has an LLM call inside of it to generate some SQL. So I can actually see the result of that call here. And I can then see the result of the actual SQL as it's been run, so the data that comes back. And then we return to the router. And this time you can see this is sort of the messages object, if you think back to that object there, getting filled in with the user question query, the original system prompt, that first response from the model, and then now the tool response itself that brings back that data. And then this time my agent chooses to call this generate visualization function. And you could continue following it down there to see the tool calls, the different LLM calls that are involved there. So at a high level, this kind of gives you a very quick understanding of what's actually happening for each run of your agent. And you can imagine as you release this into production, you could start to see more and more traces. You can kind of see this data as it's coming through live. We're built on top of a library called OpenTelemetry, which some folks may have heard of before, but we're piggybacking on some of that logic to make sure that this can happen at a really fast and scalable way. So you can imagine you get a lot of different traces that you could go view yourself, but obviously that's sort of time consuming and that's not something that scales to measure evaluation over time. So you can also apply either LLM as a judge or code-based evals to your data as well. So if I go back to that same, or go back to one of our traces here, and I look at our router call, I can see there's a feedback tab here. If you click into that, you'll see, in this case, an LLM-generated evaluation for this particular call. In this case, evaluating the tool calling aspect, so the routing aspect here. So it's actually evaluating both the function choice and then the parameter extraction step. And you can see the actual explanation behind why it chose that particular label. And so I could dive in to get more information. I could run other evaluations on top of that. But one thing that's always just kind of curious to see is we have some cases where our tool calling eval failed. So maybe I want to go in here and actually say, okay, let's look at all the ones that are not correct. I see my couple incorrect responses. So I could then click into this and see, okay, it's failing because it, in this case, called an extra method that was not needing to be called in this case. So it made an extra tool call than it needed to make. So I could take this from here. I could annotate it if I wanted to. I could also just grab this from here. And if I go into this playground piece, I can use this to actually iterate on the prompt or the tool definitions that I've used. And so I could go in here and actually modify my tool description, maybe change some of the wording here to get my router to not actually choose to call that extra tool. And I could actually just test this directly in the platform to see if maybe some of those changes would have the effect that I wanted to. I could even go further from here too, and not just test this in one example, but I could test over a data set. So if I have some examples of tool calling, I could actually test my new prompt across that particular example as well as we go through. I'm running up on time. There's plenty more in the platform I haven't shown you guys. Everything from experimentation and measuring kind of other skills of your agent using experiments and kind of ground truth comparison, some other features within the playgrounds, prompt management. So there's a bunch more in here to check out as well too. But wanted to kind of give you guys a quick picture of how we would use the tool to evaluate a real world case of an agent. And I think I'm right on time. I don't know if you guys are doing questions, but I might be able to take one or two questions. Natan, I'll defer to you there.
Thank you, John. I think that was really great. Thank you for your time and participating in AI Day.
Awesome. Okay.
Hey everyone, thanks for having me on. I'd like to.
Hi, Harrison. Welcome to Anote's AI Day. We're all very interested in learning about your coding agent. So you can just give us like a short intro and then start with your presentation.
Right. So my name's Harrison Muchnick. I do a lot of freelance work in the AI field, and I also work on a lot of personal projects, including a startup called Pomu.io. But I'm here to talk about Aslan, so I'll just go ahead. Aslan is the world's first Dockerfile-based autonomous data analysis coding agent. Basically, what that means is that it uses Docker files. Actually, let's go in chronological order. The problem is that we need coding agents that will generate error-free code from simple user prompts. Obviously, this is a problem because when you ask an AI agent to generate code, a lot of times there'll be syntax errors. It will use deprecated libraries, and there can be a whole host of issues. So this is what inspired the solution I came up to this problem, which is essentially an autonomous coding agent with a focus on data analysis applications, but it all works through a Docker file. So instead of some of the other autonomous agent solutions that depend on running individual commands one at a time and doing many LLM calls, I designed this system to be as efficient and robust as possible. So here's an example basic workflow. The user enters a prompt, print hello world. Their test conditions are no errors in output. And then the code is generated. So here there's a Docker file. It uses the Python 3.10 Slim base image, and it uses the entry point as hello world.py. It created a README and, of course, the basic script itself. And the output, obviously, was hello world because this is correct code. Now, this would autonomously continue if there are errors or the LLM determines that the test conditions are not fulfilled. So this goes in the order of generate code, run locally, validate output, generate code, run locally, validate output, until the test conditions are completed. So now I'll give a live demo here. So this is an example Kaggle problem. There's a bit of lag on my side. Apologies for that. So anyway, in this Kaggle set here, the problem is to predict whether a passenger was transported to an alternate dimension. And this is the CSV it provides. And essentially, it's just a prediction task, pretty basic stuff. So I can download these, and I can my downloads, export it. I can drag this into the input directory. And obviously, it's just the sample submission test and train.csv. Now, what I can do is I can give it instructions, which in this case, I'm just going to copy the information here. So if I do this, so is there any other information we need? Yeah. Now I'll tell it to use a random forest classifier, output the submissions.csv in the working directory. Also print out the accuracy percentage in output. And then I'll just say for test conditions, no errors in output. Let's say accuracy percentage must be greater than 75%. If I chose any higher than 75%, it would take much longer trying to figure out the proper way to like fill in the empty data points in the set. So this was the prompt. This was the test conditions. I provided the files, and now it's going to start the autonomous process in real time here. So first it does a validate output where it's assessing the input files. Then it's generating code based on that. So here's the README, spaceship Titanic prediction, Docker file here. It installed these packages within the Docker file. And here's our main script here. Now it's at the run locally stage. And there is an error predictably because LLMs create error when they generate code. So then this error gets sent back, and the LLM assesses the error, assesses the current state of the code, it provides the suspected files for the issue. For the unsuspected files, in order not to crowd the context window, it just provides just summaries of it. And now we're on to the second generate code iteration. Okay, here it is. Now it's going to run this locally again. We'll wait for that result to come in. While this is going, I also have this version of the code that works completely locally. It supports any model that that's available on Ollama, which I'm pretty excited about. I can't demonstrate that here because I'm on my laptop, but that's something exciting I'm working on in the future so that you can run this in any place without internet, and you can be assured that you'll have complete data privacy because obviously you'll be running everything locally. So now there's a different error here, and gives a description that telling it to do something about one-hot encoding. Now it's going to generate again. What's interesting about large language models is that even if you set the temperature equal to 0, it's still a completely non-deterministic system. Like before this event, I tested this exact prompt here before. In this instance, it took 2 minutes. In this instance, it took 8 minutes, but the end result was still the same. It still got, in this one, it got 77% accuracy. In this one, it got 78% accuracy. So it's interesting how the system works, because even if you set the temperature equal to 0, which in that case, it's just doing the mathematical calculations and it's just choosing the maximum probability next token, it's still not deterministic, which I think is a pretty interesting concept. Anyway, while I was yapping, it finished. So let's see what happened here. So there was this error. It validated the output, generated code. So this is the code here, and ran locally, 78.09%. It returned true, and that ends the workflow. And all of your outputs, so this is your input directory, it's the output directory. All the outputs are saved here. So all my previous runs are also saved here. And in this case, it is here. So we have the Docker file, the main.py with all the code, the submission.csv. So this is the CSV it generated when it ran the random forest classification algorithm. And obviously the input directory is also here. So now there's always a risk with live demonstrations that something will go wrong, but I've decided I want to try it on a new problem that I've never tried before. So I'm just on Kaggle here. Let's see, do something simple so it doesn't take forever. Let's see. Sure, housing prices, why not? Let's see. Data is all. Let's delete this because we don't need that anymore. Drag this into the input directory, and what's in here? Okay, so it has sample submission. Okay, pretty standard stuff. Now let's construct our prompt. So it's talking about okay, just copy this. We don't need this anymore. Let's predict this. Data. This is good information. Okay, that should be enough context. Let's say, let's just say to use scikit-learn to solve this challenge Output results in submission.csv in the working directory. What else? Accuracy greater than 75%. Okay, now we can run this. So all the workflows get stored here. This I created this front end, this basic window here. This is actually a developer tool by our friends over at Restack. They have a framework for autonomous AI, which I like, so I decided to use it for this project. So same deal. This is the input stuff. Starts up, generate code. Yeah, created these Python Docker file, readme, train model.py, and predict.py. So it can create, subdirectories. It can create as many files as it wants. Also, you can give instructions. So if you want to construct like an elaborate data pipeline where you want to say run this file first, then run that file, it will do all that in the Docker file. You can tell it to download drivers and packages. It can do that all in the Docker file. So it's a pretty cool system in my opinion, because it really is just versatile for making any type of data pipeline with any number of files. So this ran locally. So something about cache, whatever. All right, it's going to go again. It's running locally right now. Okay, it's saying no such file. Another LLM mistake, normal stuff. It's going to try again. Here it is. It's running locally again. While this is running, I'll talk a little bit about how this works. So right now, it's just a GitHub repo. It all runs locally. The commands start up, or you just change into the directory. If you're using an API key, you can add that to the .env. There's some additional configuration needed if you want to use the local LLM, but it's not too difficult in my opinion. And then you run the commands docker compose up, and that will just start up everything. And then you'll be able to open these two windows here, localhost 5233, localhost 8080. So this is still running. All right, it's on an unrun. Look, it's on another run locally. While this is running, I'll talk a little bit about some ideas I have for the future of this project. Some of the most recent features I've implemented was the input directory, so you can add files or even just a current, entire code base, and it will just work with that as the starting point. Obviously, the local large language models, it works well with DeepSeek running locally. I want to make I haven't made any changes to the UI since when I first started, so I want to take some time to also make the front end a little bit nicer. Right now, it's a bit basic. I also have just some research ideas that I want to pursue with this. For instance, one idea is if you web scraped a number of personas from the internet, like just basically people's profiles, like, oh, this Shelly is a swimmer who loves French cuisine, and then you just inject those into the prompt and then ask it to make up a problem and then solve it. That should result in a diverse data set of guaranteed working code files that can then be used to either create new benchmarks to evaluate models on, or fine-tune models so that they're better at generating code. That's something I'd like to pursue. in the future as well.
Thank you, Harrison. Those were some really nice ideas.
Yeah, so an update on this is it's been running. Now there's no more errors. It's talking about this validation here, create the file. It should wrap up in a second here. The kernel does not handle missing values. So yeah, sometimes it can be a bit strict. So even though it's outputting correctly, it's still not completing the workflow because it's saying that it doesn't handle missing values well enough. But
Yeah, that's fine. Thank you so much for presenting today.
oh yeah, sorry about that. I kind of lost track of time. Thank you for having me.
Hi, Jared. Welcome.
Hello, how are you?
Good. I'm just gonna give like a quick intro, and then you can share your screen in the meantime.
Perfect.
Yeah. So Jared is the founder of Prompt Layer. He's going to be talking to us about Prompt Layer today. It's a groundbreaking platform designed specifically for prompt engineering teams with a robust background in software engineering, including creative roles at Tecton and Google. Jared has consistently pushed the boundaries of technology and innovation, and we feel that his extensive experience in developing tools can enhance the user experience and streamline the processes. And I'm really excited to hear about your talk, Jared.
Amazing. Amazing. Well, thank you for having me, and excited to chat about prompt engineering and show you guys a little bit of a demo of what we've been working on. Maybe I'll give a little bit of a context first. We're Prompt Layer. I am one of the founders here at Prompt Layer, and we're a prompt engineering platform. So we basically launched this product about 2 years ago. A little over 2 years ago. It was originally an internal tool we built for our team, and when we launched it, we got a lot of excitement. So we dove in, and we're Prompt Layer now, and we do a lot. We do prompt versioning, prompt management, prompt evaluation, testing, analytics, monitoring, observability, the whole suite of things, but we're really in service of this new type of work we call prompt engineering. And it's really a new skill set. It's a new core competency that we believe basically every team that's building AI will need. And think about it. If you're building an AI tutor, the engineers will build the tutor and the app and all of that. And they could build the first version of the chatbot, but how do you actually make that chatbot good? We believe the way to do it is having prompt engineers who actually understand the domain context. So we've actually built Prompt Layer in a way where it should be usable for both engineers and non-technical subject matter experts. So let's dive right in. Demo's always easier than me talking. So yeah, this is Prompt Layer. This is what happens when you log in. By the way, you can try it out yourself at promptlayer.com. It's free to try out. We actually have a lot of free users using our platform. And we also power a lot of real hardcore AI teams. So it's production ready, but it's great for hobbyists too. So anyway, this is the prompt registry. This is kind of the center of our philosophy and what Prompt Layer is. Think of it as a CMS for prompts. So it's basically a way I can come in here. I can click Create Prompt Template. And let's do, how about a good example of like this talk? So AI product demo, we'll call it. You are an AI, please give a product demo to the end user. So right now I'm writing my prompt in here. This is my system prompt. I could add new messages. I could do f-string, I could do Jinja, and we could say the user response. So maybe the user will start with a question. We can also do a lot of fun stuff, like we have widgets here, so I can add a snippet. So maybe I have a snippet of what my actual product is. But for now, let's just say you are demoing Prompt Layer. Let's see if it knows what Prompt Layer is. So I can also add some parameters. So we support OpenAI, Anthropic, Gemini, DeepSeek. We support basically every model. Let's leave it at OpenAI for now. And then one thing I'll say is we've actually developed something we call prompt blueprint, which means you can run this on any model and it's still the same prompt you're looking at. So let's create it. All right, now we have version 1 of our prompt, and maybe I want to edit it. It doesn't know which prompt layer I'm talking about. I could say the prompt engineering platform. I'll call it the first prompt engineering platform. And now once I've saved it, you see I could see a little diff of what's going on. I could say explain prompt layer. And we have the option to run kind of a CI/CD style evaluation. So let's not do that now. I'll show you guys that later. I'm just showing you the core workflow of prompt layer. So everything revolves around here. I have version 1, I have version 2, and which one is better? That's kind of the whole problem we're solving. So, all right, I have version 1, version 2. Let's open it in Playground. Let's try it out a little bit. So as you see here, I have the user question. I could try out some input variables. So maybe I'll say, what is prompt layer? Done. And then maybe I want to add another input variable set. And I could say, how do I sign up? And now I could just try running it and seeing what the outputs look like. And this is how I kind of like test different things all at once. And we really believe that there's no one right answer to prompts. So we don't want to write the prompt for you. We want to give you the operational tools to test it yourself. So, all right, I have a few. Maybe this one gives me the bullets. This one doesn't. Maybe I could change it around, see how it would change this. Or I could save it as a new version, but let's go back for now. All right, so I have 2 versions, but maybe version 2, I'm still testing. We could add prod to version 1, so that's our production version. And version 2, maybe I want to add dev or staging or something like that. So now in the code, when you set it up, let me just open the docs. We'll just search run. Basically, how it works is you're doing pl.run with your prompt name, and you could also specify a label. So I don't know where that is in my docs. We got to update some of these docs, but as you see here, you run it with the prompt name. You could also specify, here it is. You could also specify prod or dev, and that's how you roll out and deploy new prompt versions. So right now that's prod. We can easily start an A/B test here by doing that, but I won't do that for now. So this is hold on, sorry. This is the core of prompt layer. And now let's go even deeper. So this is another prompt I made. Sorry about that. Something down the wrong pipe, but this is a prompt that tells me what to wear every day, given the date and given the weather. As you can see here, we can see how many times it's been used. We can see historical runs, and I'm A/B testing these 2 versions. So let's go to version 10, and let's check out the run from 15 hours ago. All right, here, February 12th. We're based in New York City. By the way, we're hiring, but let's get back to the demo. We're based in New York City, and you can see what I was supposed to wear today. It's pretty cold. Yeah, it's not great here. But maybe this is not the right output. I could add it to a data set of failing examples that I can then use for testing, or I can open it in the Playground and kind of try it out again and try to get a better response. We could also just kind of go through our historical runs here on the sidebar. We could see traces. We have a whole observability side of this platform, but let's go back to the core. Let's go back to the registry. Let me show you another cool thing. So prompt layer, it's really a collaborative tool. It's really a way to get your whole team doing this, to bring in the non-technical users, and to do this robustly. So you need evals to do that. As you see here, we have percentage passing score on each version of our prompt template. This is the cool stuff to me. Also function calling, we support function calling for all models, of course, but let's go into this eval. So here, let's hide this. I'll show you what it is in a second, but here I have a data set of questions and answers. I run my prompt, and I'm actually using an LLM as judge to see if these are the same thing and grading them yes or no. So we'll go through these and we'll check them out. Here, I'm actually doing an end-to-end test where my prompt takes in some RAG info, and I'm actually calling out to a RAG endpoint and plugging that into my prompt. But Let's not worry about that for now. This is how I'd be testing prompts. I'd run multiple of them. And we support all types of evals. Our philosophy is there's no one size fits all when it comes to evaluating prompts. Basically, everybody has to do it in their own way. So I showed you that question and answer. You can also, here's one with SQL. I have a question, I generate a SQL or SQL query, and then I'm actually running it via an endpoint, getting an answer, LM as judge. Let's try a different one. Here, yeah, backtest is a good one. So here, I've actually just created a data set based on historical weather runs, and I'm just comparing the two and seeing how they differ. So here, they're the same. Here, they're a little bit different. And that's how you would compare different models and stuff. So here, I'm running a summary on 3 different models and seeing how it's different. Our eval builder is just a pipeline on top of a data set. So let me show you one more cool thing with our product. It's called agents. It's a new feature we're working on. It's going to be out of beta in the next few weeks, but you can use it in beta. People use it in production already. Basically, it's taking one step higher. So we're saying bring your prompt business logic into prompt layer, version it in prompt layer, and now bring the ordering of the prompts one abstraction level higher also into prompt layer. So here, I'm taking in a question. I'm running it through Claude, Gemini, GPT-4o, and Grok. I'm combining the results and I'm choosing the best answer. And this is kind of my AI doctor, or maybe you could call it LM as a jury type of prompt. So this is my agent. As you see, I'm versioning it. I have prod, same thing we already learned about. But now I can use that in my evals too. So let's get out of here. Here's my AI doctor agent eval. So I'm running question answer. I run the doctor, and then I compare it with my ground truth answer. And I'm even doing a cosine similarity with the two. So yeah, you could add that to a new data set. I could compare that to a few. I think I have a cool example of comparisons here. Is this it? No. Whatever. I gotta update some of these things, but this is a cool one. This shows you how to grade summaries. You see if anything's leaking from the prompt. If it's using Markdown, you can kind of create a whole rubric. And yeah, we also have A/B tests. I think I mentioned you could fine tune. We have an analytics dashboard, and yeah, that's basically a pretty quick demo of our platform. We're a prompt engineering platform. Our goal is to help you actually make your LLM product good in a very operational way, both with engineers and non-technical users. I think you'll find by using our product that it's not snake oil. We built this very much with users in mind, so it does a lot, but it really you're not gonna grow out of it. We've thought about it all, and we use our own product for a lot of AI stuff we do internally. So you could check it out at promptlayer.com like that. We're based in New York City. You can find me on Twitter or X at I'm Jared Z. Contact me there if you have any questions. I'm always happy to get on the phone and hear about how people are using PromptLayer or how you're struggling to use PromptLayer. That's how we make the product good. So thank you for having me, and hopefully this was interesting.
Thank you so much, Derek. That was really interesting. And yeah, please do check out the LinkedIn page for Prompt Layer. And Jared's hiring, so please keep that in mind.
Yes.
Yeah.
Yes, we're hiring for engineering roles in New York City. So reach out.
Yeah. Thank you so much, Derek.
Thank you for having me.
Hi, Derek. How are you?
I'm doing well. Hi, Sphia.
So I'm just gonna give like a quick introduction. So I've heard a lot of good things about Derek from Nathan, and he's the CEO of Solida. And yeah, I'm just gonna let you take over now, and please like feel free to share a little bit of an introduction if you think there's something unique about you that we can get to know.
For sure, for sure. So yeah, I'm a research scientist turned founder of a startup. My research was in dialogue systems and conversational AI, and that's the underpinning of a lot of what I'm going to be sharing about today. Because a lot of the research that has been done in the past is actually all about what's called dialogue state tracking and NLU. And then we actually don't see that too much today. And so I'm going to be introducing an old new paradigm of how to be building AI agents around understanding before action. So assume that you want to order some food. You ask the cashier at the counter for a burger. What should they do? Do they just enter your order and then you pay and you're done? Well, actually, that's not really right. They might actually ask you something like, do you want a chicken or beef sandwich? Do you want a single or a double or maybe even 3 patties? Do you want some cheese? And the classical question, do you want some fries with that? Why are they asking all these questions? It's because it's their job to understand your full intent before taking any actions. But this is sort of low stakes. Let's suppose instead that you're at the doctor's office and you say that you feel a pain around here. Well, is that your throat? Is that the neck? What sort of pain is it? For how long? The doctor is going to ask you all of these kinds of questions, like what symptoms you have, because in her head, she's trying to take all of the world knowledge that she knows about into the situation. She's actually thinking about all of these different types of options that could be a result of that simple neck pain in order to be able to narrow down into the particular path of answers that solves your specific problem. So once again, the actor here is trying to understand your experience before taking any action. Well, to put it more bluntly, the doctor is not just an LLM that is giving a wall of AI slop every single time you enter a prompt. When you say that you have neck pain, rather than just giving an answer, the conversation is going to be a little bit more structured. And the doctor is going to walk through different options in order to get to the right answer. In general, we can really look at interactions with humans as much more fluid. When you work with a colleague, you don't just give instructions, you have a conversation. There's some back and forth as you work through the problem. And we really believe, shouldn't AI agents be the same? Well, that's exactly what we've built at Soleta, is useful and reliable AI agents that engage in listening as well as talking. Now, a lot of AI agents these days are kind of just built as wrappers around LLMs that can receive an utterance and then give a coherent response. In the past year, they learned to maybe retrieve documents and use some tools, but ultimately, they don't really understand what you want most of the time. Now, in our case, our agents are able to respond with domain expertise. And this is accomplished by really analyzing the situation first and then deciding if additional context is needed. In other words, natural language understanding. Based on this understanding, our agents will then ask for clarification as needed to engage in a real conversation. And what we believe is that useful and reliable AI assistance is only possible when the agent first aims to understand before taking action. But this intuition isn't just our feeling. In fact, natural language understanding, or NLU, is an entire field of research within AI, spanning topics from intent detection to slot filling, question generation, and ambiguity management. I would know because some of those papers that have been done are ones that I've worked on in the past with many esteemed colleagues. So this is great in theory, but then how does it play out in practice? Let's give an example. Suppose that you are a marketing manager and you want to ask the questions of how are my campaigns converting? And when that happens, though, you still really need to figure out what do we mean when we say conversion? These are the questions that we really need to understand before moving forward. Now, this is actually quite tricky. If we say something like, show me our best converting campaigns, we actually might say conversions are signups, or maybe they're purchases, or they might actually be email logins or other views. Dealing with this is not that simple. There are various trade-offs in complexity. When we're building out a dialogue state, if we have something that's too trivial or too basic, then it's not going to be powerful enough to handle the complexity found in real life. If you go the other extreme, then there's traditional semantic parsing, but this requires a PhD in linguistics to understand this tree of nouns and verbs and subjects that you maybe have studied when you're grammar school. And so as you look at these two, practically speaking, we actually need to have a dialogue state within our agent that is complex enough to model the real world, but also simple enough to label at scale. Now, this is what we've built instead, is Dana. Dana is an AI agent that works with data in your spreadsheets, that operates in the complexity of real life. Dana will integrate, clean, and transform your data as easy as talking to a teammate. Dana does the work that no one else wants to do. There's no longer a need to wait on the data team just to make one change. And most importantly, because of this understanding, Dana has reliable and trustworthy answers because Dana is really trying to do something well before moving forward. Now, how does this actually work in detail? Suppose that when you're having a conversation with your agent, you say something like, fill the empty rows in the spreadsheet with the average CTR from last week. In this case, rather than just moving forward, we're going to pass it to our natural language understanding in order to say that the task is actually resolving nulls because of empty rows. Because you said CTR, we're going to say actually the metric that you care about is called click-through rate. And because you said last week, we're going to know that this time period is actually last week. Then we're going to pass it through our AI reasoning engine to calculate this actual metric. And because we know click-through rate is the name of the metric, we actually have a formula that is like coded in that's not going to make a mistake and not hallucinate. And only after we have a reliable answer will we generate a response back to you. Now, in more detail, the good explicit dialogue state should allow the agent to have its own belief of the world. In other words, it should have a world model. Additionally, a good dialogue state is viewable and observable and controllable. Next, states can be stored and retrieved for indefinitely long periods of time. And so with all of this, this is what allows our agents to do a much better job. And we will carefully engineer this in a very special way. So digging one more level deeper, rather than just high-level intents, we actually are imbuing our agents with dialogue acts, which gives us hundreds of building blocks that we can then mix and match. So for example, suppose that we had an intent, such as a query. I just want to query something within the spreadsheet. Then the associated dialogue acts might be something like filtering or grouping, sorting, joining by different types of columns. Let's instead assume now that our intent is to graph something, create a visualization. In this case, our dialogue acts might be something like creating a chart type, or a time range, or looking at a format. As a final example, suppose that we just wanted to chat about the data. Then that's our new intent, but our dialogue acts might include something like brainstorming, reviewing code, or answering FAQs. In total, these types of building blocks give us a very powerful abstraction that can be easily adapted for new domains. This basically follows directly from the NLP research, which has a task called dialogue state tracking. We can extend this even further to also include custom slot filling for even finer grained control, such as filtering for certain brands, grouping by certain months, sorting by certain metrics. Overall, what we get then is an agent, which the first one is called Dana, is a data analyst who understands. The way we build this is we start out with a blank agent. And as a company, Soleta first builds in an existing worldview. As we add on to this, Dana will listen to you and add your specific context and preferences. And then as the conversation goes further, there's a full understanding of your situation before acting. And so overall, what this shows is that when we want to calculate something like conversion rate, we're going to have multiple turns of conversation before moving forward to make sure that the answer is correct. And so this is just a quick conversation snippet where the user has started the conversation by asking about conversions. And as you can see at the very top, Dana was already asking questions about the activity type columns and viewing site or viewing product. The user then comes back to answer this question. A visit refers to the visit site activity type, and you can join with purchases table using the user ID column. Even then, Dana will continue to ask questions. Should I use checkout or add cart as the conversion event in the activity type column? So over here, if you look at the actual chart, you'll see that there's an activity type in red, and there are different types of activities that define what is an actual conversion event or a visitor event appropriately. Only afterwards will Dana actually move forward with the type of action necessary to get the job done right. Thank you for listening. I'm now open for questions and feedback from the audience. Surya, anything that we should mention?
No, I think it was absolutely great. Do you want to share your socials? Okay, you've already shared your Twitter, but if you want, you can like tell us your LinkedIn also, and I'm sure the audience would love to connect.
Yeah, so my LinkedIn is just
Okay.
also at Soleta at AI. Definitely follow us on Twitter. We've done a lot of these kinds of video updates. And just like many other companies, we're also looking to hire amazing ML engineers. So if you're working as an ML engineer, please come talk to us. If you're a marketer who needs data to be cleaned, we'd love to talk to you as well.
Absolutely, that's great. Thank you so much, Derek. Thank you for joining us today.
For sure. Thank you so much for having me.
Hi. So I'm just going to give a quick intro and then you can get started. We have here Didier, who's the visionary founder and CEO of OpenBB, where he's at the forefront of building an AI-powered research and analytics workspace with a robust background in control systems and extensive experience in sensor fusion and software engineering. That's a lot of good experience. So I also have like a engineering background, so that's great to know. And I'm also an instrumentation engineer. Yeah, so I'm sorry if I butchered your name.
No,
So
it was good. It was good. All right. Can everyone see my screen? I'm assuming
yes.
yes. Okay. So hi everyone. My name is Didier. I'm the co-founder of OpenVB. Today I'm going to talk a bit about our agents and how we do function calling mostly into the product. And so this is our product. This is the OpenVB workspace. What you're seeing in the middle is basically the dashboard that you can control, fully customizable. These are widgets with the relevant data for you. On the left side, you have a sidebar that you can control the dashboards, the folder organization, who you're sharing it with. You have templates, you have your data connection. And then on the right side, you have OpenVB Copilot, which is effectively our agent, which works as an analyst that has access to all of the data inside the product. And we're going to talk more about it. And so what our agent does is a lot of function calling. So an example of function calling is, let's say that you want to get access to earnings transcript. You will call an earnings transcript endpoint with the right ticker, the year, and the quarter that you are looking for. That is just an example. And so you interact with these agents on the right side of the product. And so if I were to ask, who are you? You'll say, I'm OpenVB Copilot, your agent for data analytics. But in this case, no function calling was used because I'm asking a question that does not require anything else, right? It doesn't require context. And so this is basically when function calling gets used into our Copilot. And so how do I provide explicit context onto OpenVB Copilot? Let's say that I'm asking some question. Let's keep the example about earnings. What I could do is I can get the widget that is the earnings transcript widget that has all this data. I could copy everything and then I could paste onto the Copilot window, right? Well, that's not really nice, right? There must be a better way. And so the better way that we could come up with is by utilizing these icon on the top right that basically allows you to add a widget directly onto the context of the Copilot. So you are basically explicitly mentioning these. I want to refer to the data within these widgets. And that's how we provide a great user experience for the user. And so what happens if you don't tell the Copilot what widgets to utilize? Maybe you want the Copilot to have access to all of the data on the dashboard. Well, that is not a problem. So what happens is, in this case, I ask the question like, take the earnings questions from the widget and answer them for NVIDIA utilizing the earnings transcript, okay? And I didn't provide anything as data. And so what you can see here on this area is that the context is using the dashboard's widgets. So now you are basically relying on the agent to select what are the widgets necessary to answer the question that the user has asked. And so here, actually, on the top, you'll see the step-by-step reasoning, which you can open the collapsible, and it will tell you everything that is happening under the hood. So it will tell you, okay, I want to get the earnings questions for NVIDIA, and then I want to get the earnings transcript for NVIDIA. It selects the parameters, the widget ID, and it gets the right data to be able to be processed and then answer to the user, which in this case, as you can see, it answered correctly, okay? And so how does the Copilot know that there's an earnings transcript in the dashboard in the first place, right? Because like, how does that even happen? So we came up with this concept of metadata, okay? Each widget into our product is basically a widget is a component that has the data, where it comes from. It has the interface, the visuals. So it could be text, could be a chart, could be an image, could be a mix of both. And then it has these metadata. Think of it like as the widget signature. And that's composed of 5 components, which is basically the title of the widget, the category, the subcategory, a description, and the data source. And this basically is converted into embeddings, which we compare against the user prompt. And then we have this big widget reference library. And based on that comparison, we will give those function access to our Copilot to utilize to answer the user prompt. And so that's how we allow it to scale as well as it does. So what if the relevant data is actually not on the dashboard? So imagine I have done the integration to the product, but is not something that I've added into the dashboard directly. That's not a problem, because we have a feature flag that you can turn on that allows you to search across all the widgets on the interface. And so this is like super powerful, because now you can have the AI being the one looking for the right data to put onto the screen. And so this is our example of a data connector page, where there could be thousands of widgets that you bring. Could be CSV files, PDFs, and structured data. Could be an API endpoint. Could be a Snowflake. You can build a custom backend. We have like open source that integration layer. And so it's up to you to decide what type of data you want to bring and what is the workflow that you are wanting to achieve on top of OpenVB. And we have also some widgets that we have integrated out of the box for you. And so here's how it works. So let's say that I ask, what is the latest data on the US yield? What happens in this case, it retrieves the data to me. But as you can see, there is no widgets here with the data for me to utilize. But when you over here, you'll see that this is basically doing a citation for the yield curve. And you can see on the step-by-step reasoning here on top, like what happened. As you can see on the step-by-step reasoning, that is looking for all widgets that have anything relevant to US yield data. He understands that there is an OpenVB API integration. He processes the data and he generates an artifact. Okay. And so when you actually over on top of the citation, you are able to add the widget to the dashboard where the data was sourced from. So it's from the original endpoint integration. And so in this case, if I were to click on add widget to dashboard, then you get the original source. And this enables you to, okay, let's say that you want to validate whether the Copilot gave you the right answer. You can have the original widget on the screen to compare against the answer that was done. And this basically avoids hallucinations. So now we have explicit context, clicking on the button to add onto the window. We have the dashboard context, which is when it's available on the dashboard. And we have the global context that is enabled to a feature flag. How does the Copilot navigate this? Well, it's very simple. Explicit context takes priority, then is the dashboard context, and then finally is global context. So the same way as an analyst, you'd be like, okay, if someone gives you a document and asks you some task with the document, you're going to use that. If you have a bunch of documents on your desk and you are asked to do a task, you'll maybe go grab onto those. But if you need something a bit more deep, you'll go onto the Google Drive or the Slack to look into more information than the one that has been given like right in front of you. And so this is the same way that our Copilot agent works. And how does the Copilot get the data? So again, everything is a function call, which is the title of this presentation. And so I just want to share with you some examples on how this works. So let's say that I'm going to do a function call to an unstructured data widget with no parameter changed. So basically what happens is, in this case, I'm asking something along the lines of extract the total return in USD based on their year-to-date of all equities mentioned, then sort them from the highest total return to the lowest and return it in a table format. In this case, I have the widgets on the screen. And what happens is that the Copilot understands that I'm asking something in relation with this document because it's right there. So he understands the context and he doesn't need to change parameters. So what he understands is that, look, the metadata of this report is a capital market outlook report. He understands that this is what I'm asking. And then I can see the step-by-step reasoning where the first query that the Copilot thinks of is, I need to identify first all equities mentioned in the report, and then I need to extract them. And so he understands that it's available on this report, and you can also over on top of the citation and click on go to reference, which will highlight where the data was extracted from. So this is really powerful to analyze like capital market outlook reports or sell side reports or any other type of document that is complex and that you want to have like a reference to. This is what I showed. And then, of course, this data is extracted as a first step, and then it's processed in a way that the user has asked. So in this case, I asked for a table with it being sorted, and you can see that the Copilot did exactly that on my behalf, which is what I'm looking for. Now let's go to a more challenging example, function call with a parameter that is being changed. So in this case, what we're seeing here is I have the company news is looking at Apple for the past like 4 years. And then I ask, in the last 2 days, summarize the news for Palantir and what is the overall sentiment, okay? And so this is an interesting query. When we look at the metadata, you'll see that the metadata says, okay, this is the company news widget. It retrieves news articles, including events, announcements related to a particular company. And you can see that the data source is Benzinga. And you can see the parameters here that in this case is looking at Apple. But well, I'm not really asking about Apple. I'm asking about Palantir, right? And so what happens is you can see on the step-by-step reasoning that there's a query that says, show me the news for Palantir in the last 2 days. And when we access the widget, you can see that the ID is company news, which is this one. But you can look onto the parameters that are being sent. And the symbol is not Apple, the symbol is Palantir. And the start date and end date are 7th of February and 9th of February, because the last 2 days when I did this query, which was 3 days ago, is basically this. And so the Copilot understood and converted my prompt into the right parameters to do function calling into that widget to retrieve the right data. And so that's extremely powerful. And so this is what it looks under the hood. You can see that the payload on the request has the right start date, has the right end date, it has the right symbol, it has the right provider. And then you can see that I get the right response for under the hood, which then is parsed onto the is given into the Copilot and then uses it to answer the question that I have asked. So that is really, really powerful, because now you see that the function calling has basically control over the input arguments the same way that an analyst would have. And so one thing that you can do is that you can actually click to add that citation on the output of the citation onto the dashboard. And now you can see that what I see on my dashboard is this company news with the right ticker and the right dates that have been sent. And so it allows me as a human to analyze the data the same way that the Copilot has, but here is like in its raw format. So in this case, the Copilot processed it a bit more to do something that I've asked. And then the final example that I want to show is like multiple function calls to structure data widgets. So this is a bit more complex. And so what I'm going to do, I'm not going to spend too much time on it, but basically I ask, analyze the settlement prices of full-size gold futures and e-mini gold futures to identify potential arbitrage opportunities or refine trading strategies. And I say, okay, follow these steps, because I want to be very clear around like what I want it to do. I'd say these are the symbols, GC, QO, and I say the maturity date is this date. And I say for the last 20 days, I ask to compare the prices, calculate the ratio, and create a line chart. Okay. And so what happens is that you can see that at the end of these process of the Copilot, you actually get the price difference chart, which is exactly what I wanted. But so how does this happen? And so when you look into the step-by-step reasoning, you'll understand that, again, what happened is we understood that these widget ID has the right data that we want because of the description associated with the widget metadata. And we're going to query it with the right symbol and the right maturity date. And we're going to do a query for this symbol, GC, and we're going to do a query for this symbol, QO, which are based on the questions that I've asked. Now, once that is done, that basically means that I can create an artifact. I can create an artifact. In this case, is a table with the date, with these two different symbols, and with the price for each symbol on that specific date. And it does that for the last 20 days, which is what I asked. And then there's the next step where basically the Copilot processes that data, and does the difference and creates the chart for me. So this allows you to see how powerful our workspace can be, because now you can go from raw data format into getting an output that is exactly what you wanted to see, because you had all the data, and the Copilot is the one to do the function calling as a human would. So the Copilot is selecting the right parameters based on what you have integrated into the product. And then finally, to wrap up the loop, once you have this output, in this case, this price difference chart, what you can do is you can click on this button, which creates a widget directly from the chart. And so that means that I can now create a widget from this output from the Copilot, and could be a chart, could be a table, could be a text, and it goes onto the dashboard. And now I'm able to share that dashboard with my manager, with an analyst, with my CIO, or anything else. And so this wraps up my presentation. The Copilot is free to try. You can go to openvb.ai. We've crossed 83,000 users recently. And so if you have any questions, you can find me on Twitter, dd_lopsh, or on LinkedIn, and I'm happy to chat with you. And yeah, sorry to be a bit rushed, but I wanted to make sure we went through everything.
No worries. Thank you. That was really great to hear. And please do share your email in the chat, I guess, so that if there's any questions, people can reach out to you later.
Sounds good. Thank you.
Thank you. Hi, Dan.
Hi there. Am I all good to go?
Yeah, I'll just give like a quick intro and then you can get started.
Great, thanks.
Hi everyone. Dan is here, and he's a senior generative AI product specialist at Databricks, where he leverages his extensive background in AI and machine learning to drive innovative solutions. With a master's degree in data science from NYU and a wealth of experience as an AI/ML engineer at JetBlue and OpenSignal, Dan has consistently demonstrated his expertise in developing cutting-edge technologies. And with that being said, we're very excited to hear about whatever you have today, Dan, and you can get started.
Awesome. Thanks so much, everyone. For those maybe a little unfamiliar, Databricks is a cloud computing platform that sits on top of things like AWS, GCP, Azure. But for us, we're moving a focus towards going from data intelligence to being able to integrate things like AI agent systems that sit on top of your data, or even sit on top of your data and traditional machine learning models. Multi-agent systems are really core to this, right? In that we look to leverage either a suite of tools or even other machine learning models with existing LM capabilities. So I'll be focusing a lot on that. But just to give you kind of a broader view of where our customers are and where we see industry at large, right? The idea of having an unstructured retrieval, or RAG, is something that we still see customers looking to get a leg up on. Frankly, also actually see value in. Chatbots are not the end all be all, but that's kind of where we see things starting. Moving to working with actual structured data as well. You can imagine then working with both of these, right, and needing the ability to do things like routing, call different tools, et cetera, and also work with a variety of data sources. But before any customers actually get to doing multi-agents, just this process alone can take a lot of time and investment. And there's a lot of complexity involved too. It's very hard to keep track of these things. I'll talk a little bit about evaluation. But only then can we actually get to multi-agent systems, or agents that orchestrate other agents. As I said at a previous ML Ops community event where I was speaking, a lot of customers are just not there yet. We don't necessarily see this in industry as much as some of these other components, in part because of the complexity and the potential risks involved with multi-agent systems. So the broader development lifecycle of this really starts with data, and that's as critical as any agent framework, as any evaluation as you might do. Same with any traditional machine learning model. You might do vibe checks with quality, with LM judges, but until you actually get to the ability to understand, what makes for a good or bad agent, you're still a long ways before productionalizing these things. Just the fact that we have this kind of loop here between 4 and 3, iteratively identifying and fixing root causes, and creating more evaluation data to either fine tune on or provide us in context learning examples, right? These steps can take a lot of time. I'll talk a little bit more about that iterative identification and fixing root causes, but only then will you be ready to actually get this into the hands of QA testers and be able to get feedback, and then eventually release to production. But the way we look at it is, you're always going back and identifying and fixing root causes. We see cases where you might fix one part of a prompt, but then that messes up some other downstream capability. So evaluation, right, is almost more important than anything else when it comes to building effective AI agent systems. This is a much broader overview of what that might look like on the Databricks platform. There's a lot going on, I think, in part because our customers do such a wide range of different things. But a lot of what I talked about kind of links up with what we talked about before. The data piece is all centered in Unity Catalog, which provides a unified governance structure for everything from your data to models to model artifacts. But we have customers that want to work with a range of both open source, commercial LLMs, with a variety of different agent frameworks, right? We're not a platform that looks to lock in customers. But that observability and monitoring and evaluation capability is all done through open source MLflow, which is awesome because learning agent frameworks is hard enough. You shouldn't have to learn an entirely new evaluation framework too. And I'll show a little bit what that looks like downstream. We have a lot of different products here that I won't touch in too much detail on, but needless to say, you can leverage functions that work with any number of these products. For instance, like a RAG function or SQL functions as well, to then actually build agents and get those to production. I'm happy to talk more about any of this at any other time, but obviously a lot going on. The one thing I want to note here, though, is in talking about agents and multi-agent systems, right? There's a billion different frameworks to choose from. In talking with customers, we do see mostly LangGraph, but I've talked with people at say meetup events around New York who say, why would I use any framework at all? I can write Python code, I can define my own constraints, and that's something that we look to support. All these other frameworks, though, are integrated well into the system. Some of them even having their own MLflow flavors now, which makes it really easy to leverage on our platform. I'll talk a little bit about what we do more generally from a multi-agent perspective before getting into a demo. But the big idea here, and what I think is absolutely critical to bringing these systems to production, is having some kind of supervision pattern to better orchestrate the overall flow of information, and as well as just capabilities within this multi-agent model, right? I think the big issue more generally with Gen AI is that you have the capacity to hallucinate, and as you get increasingly complex systems, right, that makes it increasingly possible to venture off into weird sub branches of this tree here. More importantly, ensuring that structure is maintained throughout all of this is frankly just hard. I have been using LangChain in various capacities for a very long time now. It's almost 2 years. And yeah, in the early days of LangChain especially, that was really hard to do. I think things are improved, but you can imagine, especially if you're one of these people who's building everything out custom in Python, you're very susceptible to getting formatting issues or other kind of type constraints, right? But the solution that I'll share today for a multi-agent system looks to do two things. One is have function calling capabilities. This is leveraging our homespun vector database. We have tons of people who use external vector databases as well as Python code and pre-written SQL. And the other capability that will be leveraged here is text-to-SQL agents using a product that we call Genie. Genie is, in the easiest terms, like a text-to-SQL sits on top of all the data you might have in Databricks kind of tool. It works on top of both dashboards that we have, say, business developers or data analysts building, but it can also be called like a tool. This sits on top of Delta tables, which just think of it as like a data frame, right? The function calling piece, though, gets complicated, right? As well as the multi-agent orchestration piece, because it's not just a singular input-output, right? We need to be able to decide, have almost reasoning capabilities around what either functions or what sub-agent might be most useful for either a given question or a given type of data being input or output. So this gets complicated. I'm sure many of us are familiar with this, but with that, I will get into the demo. So what I'm going to be sharing here is a Databricks notebook. So as I said, this all sits on top of a Unity catalog data store, right? And what we'll do is we'll go through Databricks RAG Studio to obviously import things that we need, but we'll define a path of a chain. And we're going to then log that chain using MLflow to test it. And then downstream from that, register the model, right? We already have our data in Unity Catalog, but you can have your model there as well. Deploy that, and then view that deployed chain in the RAG Studio UI. So you'll see here in terms of what we're doing, right? We have a lot of LangChain. We usually have customers building in LangChain. And so if you build in LangChain, things are really, really straightforward. DSPy, another agent framework, is actually something internal to Databricks. We don't want to focus as much on the uninteresting stuff, but we can kind of start with just seeing how this would work in terms of specifying what a message might look like, right? This is pretty typical kind of OpenAI formatting. And we can define what our agent might look like. This is a little more specific. One thing that you'll note here in this agent config is we have a UC function list. So UC, that's Unity Catalog. We've already had two things in our Unity Catalog, right? We had our incoming data, right? As well as the actual model itself. But we also look at AI functions as being something that you should probably have with the same governance structure, right? So if I share like this other tab here, right, you can see the Unity catalog right on the left here. So there's tables, there's volumes for who knows what, but more importantly, functions. This is a SQL function in which we kind of have a very specified structure of input and output. I think you cannot build multi-agent systems without having these very discretely defined input outputs for your downstream functions because, like I said, hallucinations and veering off forking paths. But notably, we define parameters for this with a stock name fragment that we will use to then get information about the stock item, right? We'll get a stock item ID and a stock item name based on like a particular fragment that is being supplied here. So that's basically that. You can see like the type here. Like I said, data governance really important. We can define that only certain people can actually use this function, which means one agent might do different things for different people if you want it to. Maybe you have sensitive data that you don't want your summer interns having access to, but for general employees, that might make sense, as an example. There's also other capabilities as far as tools go. So this is a tool writer capability. And what this will do is it will actually create new tools, which is awesome, right? You can imagine your AI agent system actually evolving over time. But once that is in place, actually having a wrapper for all this with agent builders, how we'll look to register this whole thing together. We have some things around vector search as well. I won't touch too into that as that's a little more Databricks specific and probably not as interesting to folks who are very familiar here. What I think is really awesome about our AI agent framework is that it's all just MLflow, right? If you have data scientists who are suddenly being asked to try to be a Gen AI engineer or specialist, that's not a fun time. Instead, if you already know MLflow, right, you don't need to relearn a whole new ability to work with agents, right? In this case, you can see we're going to call mlflow.startrun and then mlflow.python.log model. This is very, very familiar to anyone who has spent the past building traditional ML models. We have a lot of other things here in terms of like input examples, configs, etc. Not all these are required, but you'll see how it can help downstream. But you can see that this is effectively logged. And this is, again, just MLflow LangChain flavor. But you can use this with any other kind of flavor of MLflow that is for agent systems. We'll have some questions here, but you can see what we'll do here is we'll call our loaded model, which we're notably picking back up from MLflow and running that on top of a question. What I think is so cool about MLflow now is not only is it built out for Gen AI and can support Gen AI models, but all of what you're seeing here, this MLflow tracing, is just done for you automatically, right? Like if you are debugging an AI agent system, like it is never fun. The most important thing you can possibly do is be able to dig into this, see what is taking long, right? Like we've all had these issues where, oh, this one subcomponent, I think this is doing something with an API, is hanging up, right? Maybe it's because something got messed up in the formatting. You do not know that unless you build a good evaluation system and can rapidly iterate on it. And again, this is all just given to you for free within Databricks MLflow, which means that it's ideal for closing the overall dev loop and making it possible to get AI agent systems to production. You can see that we're calling a bunch of different things here, though, right? So our initial lane graph is called. We're going to first initiate our initial agent, right? You can see that there's a downstream tool call here. There's another agent call, right, with another tool call, and we have another agent call doing something else, right? And yeah, we can dig down to any component of this and see everything from we're going to, in this case, get a registered model. And I think what that will do is then change some of the associated metadata there. So you can see what the outputs of that is, and even what the inputs are, right? Retrieval model and Unity catalog by name, right? So the last step of this, right? Let's say that we are pretty happy with this. I haven't even shown our broader MLflow integrations, but needless to say, it's really helpful for comparing, say, swapping out DeepSeek for GPT 4.0, making any other kind of changes. Actually, logging this is one thing, but getting it deployed as part of a production grade system can be a huge pain for our customers. What you can see here is when we call client.setRegisterModel alias, or sorry, when we call MLflow.registerModel, what that will do is it will make that available in Unity Catalog. And then downstream from that, we can actually get that deployed. So you see this is another prediction on top of that, but we'll do some deployment prep. And then downstream from there, all you need to do to deploy your model is call agents.deploy. And that's it. There's some environment variables that you're setting here, secrets, which can also just be managed within Databricks. But it's super, super straightforward to be able to get this from, hey, I'm playing around with this in a notebook, which as a former data scientist, that's awesome. And then you can actually do things around, say, setting review instructions and make it possible for subject matter experts to provide feedback on your agent system. It's one thing to just run this in MLflow and say, here's my data. It's another to then have it be tested by other people. You can see that review app is accessible here, which you can share with people internal to your company or elsewhere, and actually get feedback on that AI agent system. That's about it in terms of what I have here today. But yeah, I kind of just want to close by saying that the state of agents is one that has changed a ton, and we've gone a long way from just having pure LLM calls. We see agents with tools. I think we need to spend a lot more time investing in lightweight tool integration. We shouldn't be doing math with LLMs. Ideally, we can call a calculator, right? But we also see issues with overcomplicating things. OpenAI said they're double investing in reasoning models. Well, if you're building agent systems on top of reasoning models, you can fall into double reasoning pitfalls, which are super, super painful. The other thing is, we need to think back to some of our fundamentals of agents. RL has had agents for, I'm going to say, decades. And this paper from 2017, you read this title, Multi-Agent Cooperation and the Emergence of Natural Language, and you'd say, oh, I know how to build that. It's actually all RL, right? I think there's a ton of valuable research there that's currently untapped around statefulness, constraining action spaces, a lot of the things that make AI agent systems successful today that we don't appreciate. Another kind of future looking vision is open sourcing of proprietary agents. We all know DeepSeek may or may not have taken some inputs and outputs from OpenAI, but even deep research is not that complicated for people to build. I'm really excited for the world of open source. Databricks loves open source and having people build with all sorts of different capabilities out there, and really excited to see where agents go in 2025 and multi-agents in particular. So thank you. That is all I have.
Thanks a lot, Dan. Those were all really insightful things that you shared. And feel free to share your socials or your email so that we can send you any questions that come your way.
Thank you.
Thank you. Welcome, Sarah.
Hi, thanks for having me.
Yeah, I'm just gonna give a short intro and then you can get started. So we have Sarah here, who's the co-founder and CTO of Letta, where she leverages her extensive experience in AI systems to drive innovation in agent development. With a PhD in computer science from UC Berkeley and a rich background that includes leadership roles at List AI and other impactful internships at top 10 companies, Sarah is right now at the forefront of technology, And today she'll be diving more into Leta's agent development environment, showcasing its capabilities through an engaging product demo. Yeah, you can get started now, Sarah.
Awesome. Cool. Hi, everyone. So I'm going to go over like a couple slides just to kind of contextualize what we're doing at Leta, which is basically trying to make state-of-the-art agents that can actually learn. And I'll try to kind of go through quickly so we can also leave time for the demo of our new agent development environment at the end. So to kind of give context, we're basically trying to make Leta the best place to build agents so that the best agents can be built on Leta. So we really focus on stateful agents that have superior memory, reasoning, and personalization. The company was actually spun out of the MemGPT project, which kind of introduced memory for AI systems. So my co-founder Charles and I, and also our lead research scientist Kevin, were all the first three authors on the MemGPT paper. So to kind of contextualize where we're going is like we kind of believe that the agents landscape is going to shift from like these more stateless, more like workflow-like agents to actual stateful agents. And so the fundamental problem that we see is basically the intelligence of agents today is bounded by what's placed into the LLM context window. So basically the context window is all like your agent or your LLM knows within that time period. And so there's kind of a lot of challenges with properly packing this context window. If you have too much data, then the performance drops, the LLM kind of gets confused and derailed. There's a lot of recent work showing that like just because you put something into the context window, if you let your context window get too big, it doesn't necessarily mean that the LLM is actually using that information. And at the same time, if you put in too little data, obviously your LLM won't have the relevant context that it needs. It's more likely to sort of hallucinate information because it has gaps in its knowledge, etc. So this is a very challenging problem. Like, how do we basically structure context windows in the right ways to leverage what we have with LLMs today to get the best possible agents? So one big sort of effect of this limitation is that LLMs don't have long-term memory. So obviously LLMs have finite context windows, they don't retain state. And I think memory, it's not just an issue of personalization, but it also just means that these agents can't improve and grow over time because they're stateless. And obviously to improve and learn, you need to have some form of memory. And another issue here too as well is that there's huge amounts of existing data. You ideally want your agent to be able to like read all your internal company handbooks, to review all the data that you have, to derive insights from it. But agents basically aren't able to do this. They're not able to go and look at huge amounts of data and derive insights from it in the same way that humans do. So where we see the space going is basically moving from stateless agents to more stateful agents. And the idea here is we leverage a lot of the memory management work that we did with MemGPT and also extensions of it to basically make state management a core part of the agentic system and the agentic loop, as opposed to kind of add-on, which is how many systems are kind of structured today. Yeah, and so to kind of briefly go over like what this looks like in terms of a stack. So basically Leta is designed as a service. So we basically create an agent server that uses under the hood just the fast API service and Postgres to basically retain state and manage how the context window should be formatted. And so because the context window is managed on your behalf, Leta will actually manage interacting with various different API services like OpenAI, Anthropic, Olama, BLM, etc., and basically enable developers to have a stateful agent server. So if you're building your application, whether it's customer support, a companion assistant, or even some kind of workflow automation, you can basically use our agents REST API to both build agents, modify their memory, query their memory, and also deploy agents and send messages to agents. So basically everything is API based in our model, which means that it's also somewhat language agnostic. We have official Python and TypeScript SDKs, but even if you're using something like C++ and Go, you can always interact with REST APIs through those languages. So because of that, it's fairly language and model agnostic. And so what this looks like is basically Leta is a complete stack for serving and deploying LLM agents. So you have your top level application, and then this will communicate with the Leta service that basically creates those APIs. And then under the hood, Leta will basically manage things like long-term memory, extended chain of thought, and then also making sure to format your data in a way that it's model agnostic. So this basically enables separation of data and compute. So even if you have all your agents and their memories and you want to change models, you're able to do that without losing state. And so what we basically have within our product suite is we have both the agents framework, which is our open source project. This has all of the core components like the memory, the reasoning, the persistence, all in the open source. And then we have the Letta agent development environment, or ADE, which I'm going to show you today. And this is basically like an IDE for agent lifecycle management and lets you have a visual interface for kind of iterating on your agent's design, prompts, model configurations, memory configurations, etc. So now I'm going to switch over to a demo. Okay, looks like that worked. Cool. So this is basically our agent development environment. Let me actually switch to light mode. I personally prefer this. But basically, so there's a lot of things going on here, but I'm going to go through them step by step. So this is kind of similar to like the OpenAI assistance playground, but there's a lot more configurability because we kind of design things to be white box. So you can actually configure like what's the backend model that you're using. You can configure the system prompt. You can also even kind of configure the context window size. So we often recommend to people that they kind of stay around 30,000 tokens for their context window. So that's also something you can configure and you can kind of watch how your budget is being used. You can also add custom tools to your agents. So these are basically the memory management tools that we add by default to all agents, but you also can remove them. And then you can also actually connect a bunch of tools through our Composio integration, as well as add custom tools. So this is, I think my internet's not great, so this is taking a bit of time to load. But yeah, we basically have both like multi-agent tools for cross-agent communication. We have custom tools, basically a ton of different integrations where you can attach any of these to your agent. And then we also recently added something called tool rules, which if you have like certain constraints on your application and like patterns that you see for how you want your agent execution to happen, then you can impose these rules later on. And so in the middle here is basically my agent simulator. So I can kind of see like, given what I've configured so far, what is it going to be like to interact with this agent? So I can be like, hi, my name is Sarah. And so all of these interactions that I'm doing right now, including sending a message and kind of viewing all the tools and the state of the agent, you can actually do all these things with our REST API as well. So this is the interface over it, but you can, of course, programmatically do everything that I'm doing here. And so you can see here, I've told the agent, my name is Sarah. And so it decides to append to its core memory. So this is basically its in context memory that's stored in context. So yeah, there's currently 260 tokens dedicated to core memory. And because it calls this tool core memory append, it basically saves to its own memory, the user's name is Sarah. And so now you can see that the simulated memory for this like template builder now has this additional information that the user's name is Sarah. Another thing you'll notice here is like there's always the reasoning happening. So we actually, even before like the reasoning models are released, always required our agents to reason before they act, just because that can often improve the performance of your agents. And then now that reasoning is becoming a part of the models, we're also just directly using like O1 and DeepSeek reasoning to fill in these fields. You can also view the kind of what's going on with your agent with a lot of transparency. So we have debug mode. So this will show all the details of like what's being returned by the tools, the formatting of the messages, etc. And you can even actually look at the context simulator. So this is basically like the raw context window of the agent. So you can see things like the tool definitions, the message buffer, also like view the core memory directly. So this is basically the in-context memory. And so you can actually see like exactly what's being passed to your LLM. And we think that this is a really critical feature that a lot of agent frameworks don't really prioritize right now because ultimately LLMs are very unreliable. It's hard to tell like what's going wrong. And I think a lot of people who are sort of blaming LLMs for limitations of agents are actually not formatting their context windows as well as they should be. Oftentimes, if you have a really great context window, you're providing all the right information to your agent. These models are really, really powerful, so you're able to get impressive results. So we want to make sure that developers are able to see exactly what's going into their context window and also have full control of it. And that's something that's really important to us. So other than that, we also have archival memory. So this is basically like long-term storage for the LLM. Basically, the LLM or the agent has the ability to read and write from an external database. And you can also do things like load files into archival memory, so your agent will have access to that. And then once you're basically ready to publish your template, you can basically create a new template version. So this is basically kind of like creating a template that you can then deploy other agents off of. And yeah, again, like I mentioned, everything is done through the REST API. So now that I've created my template, I can create agents off of this template through a REST API and also our SDKs. So yeah, everything I've shown you here, this is actually in Letta Cloud, which is primarily focused on like templates and deployment. But this exact same UI, if you're interested in running it locally or with local models, you can actually access it with Letta Desktop. So if you go to our documentation at docs.letta.com, you can download Letta Desktop for Mac. The Windows one is having some problems, but the Mac OS one works. And then you can also actually, this is currently what I'm showing Letta Cloud, but if you run the Letta service locally, you can actually connect your local Letta service to the ADE to basically have the same visualization on top of your agents. So yeah, just to summarize, the Letta open source is basically like our core framework. It enables building next generation LLM agents with long-term memory, deep personalization, and advanced reasoning. It's also designed to be model agnostic and white box, and then also service oriented. So you don't need to worry about deploying your agents. They're services from the get-go. And the easiest way today to get started with Letta is to just try out Letta Desktop. You can download it on Mac, run everything locally. You can also connect it to OpenAI, but we find a lot of our developers like to use things just fully locally with like Olama and LM Studio. And then there's also Letta Cloud. So this is actually only whitelist only right now, but if you're interested in using it, please reach out. It's basically a way to use the agent development environment and be able to deploy and run agents with zero infrastructure. So you can have agents as a service extremely easily. So yeah, that's all I have for today. Thank you so much for listening to this talk, and please feel free to reach out to me at sarah@letta.com. We also have GitHub, Discord, Twitter, YouTube, etc. So please follow us there. Thank you.
Thank you so much, Sarah. Thank you for joining us today.
Yeah, thank you so much.
It's not bad. Hey guys.
Hi, Glenn.
Hi. How are
You can
you?
share your screen.
Okay. Should I just start immediately right now? Okay. Give me 1 second. Sorry. Is it working?
Yes. So just to give like a small introduction, Glenn is the co-founder and CTO of Stochastic, and he also has like a PhD from UIUC, and I'm very excited to listen to his talk today. Feel free to get started, Glenn.
Hello, everyone. Today I'm going to give you a presentation on about the company Stochastic, which I co-founded with my colleagues from the same research lab at Harvard University, where we did a lot of work on AI systems research, and also a little bit about what AI agents are, the remaining challenges, and how we're tackling those challenges. So as I mentioned, we started our company. I started this company with my colleagues from the same research lab, and currently, what we're building is a full stack conversational AI agent platform that provides private, real time, and trustworthy AI agents to regulated industries specifically. Our AI agents can have human-like natural conversations with customers, plan and take actions to fulfill their requests, and proactively solve problems. And we're committed to democratizing access to the best AI to ensure that every organization could benefit from privately available and personalized AI agents. We got started on this AI agents primarily through the research project that we had worked on. We invented the world's first real-time LLM inference engine that included a full stack implementation where we designed the LLM inference chip, wrote a compiler, trained a foundation model to process speech and natural language processing. And we published those results in 2021. And that kind of gave us an idea into what the full potential of transformer architecture is, but also some of the challenges to deliver a enterprise-grade, production-ready AI products. Prior to starting this company, as I mentioned, I was a CS adjunct faculty, also did my fellowship and postdoc there. And both UJ and I spent some times in the industry designing AI accelerators, deep learning frameworks, and we're luckily joined by a lot of smart people from different organizations. I'm sure you guys are all familiar with this, but we're going through a transformation in how we automate workflows within the enterprise. We started with simple rule-based automation in the 2000s with some ML augmentations, maybe that started around 2010s and beyond. And now everyone's super excited since last year because of the agentic automation. And the reason why everyone's so excited is because AI agents can potentially automate entire operations end to end, not only automating the workflows, but automating the communication between the stakeholders and also performing very complex and sophisticated decision making. But when we take a look at the current state of AI agents in 2025, there are some things that I wanted to comment on. But before we get into that, first, let's look at the definition of AI agents. I think the key thing about the AI agents is that it perceives its environment and takes actions autonomously in order to achieve goals through planning and taking actions. And what we saw in the market is that the agent solutions in the market lack agency, and they're what we describe as AI workflows. These AI workflows require tedious rule-based construction of decision logic trees. And because your planning stage or all the possibilities of an action that the AI agents could take are fixed, they're ineffective in handling exceptions. And a lot of the solutions are currently using black box APIs and fully depend on them. And because of these reasons, most of the products are reactive and not proactive. They're designed to deflect complex problems, but not solve these problems. So when you look at the agent or the autonomous agent architecture, you can see that it has multiple different components: memory, tools that it could call to perform the actions, and then the planning stage. But when you look at AI workflows in particular, the key step that is missing is the planning stage. So it's a very limited, and this planning actually has to be done using the long process of building out those decision logic trees. And when you actually take a look at then why aren't people building AI agents? Why are people just currently focused more on AI workflows? It's primarily because of certain difficulties of building autonomous agents with public APIs. Like first of all, like because these APIs are general knowledge engines, they have limited domain-specific knowledge and domain-specific reasoning capabilities. And second, because they're using public APIs, they lack the data security and privacy, which could be a limiting factor for many of the enterprises. And lastly, you have limited real-time performance with black box APIs through the transmission latencies. And when you add in additional components such as voice and guardrails, the challenge becomes even greater, which are some of the reasons why it's really difficult to build these agents. And when you look at what the enterprises are demanding, you know, um, 2025, I think compared to last year, many of the projects are now like past the POC stage, and enterprises are increasingly demanding more transparency, control, and personalization of AI solutions. And they are also demanding privately hosted options and enterprise-ready solutions. And of course, last but not least, they're really focused on solutions that would give them the return on the investments. So at Stochastic, what we're building is an AI agent platform for the enterprise. Our AI agents system can be privately hosted. You could deploy it on AWS, GCP, Azure, inside your virtual private cloud, and it could also be deployed on-prem. We provide no-code access for business users and SDK for technical users. And we support multiple different communication channels, including email, text, phone calls, and fax, supporting also multi-modality text, voice, images, and files. You could also connect with existing applications and databases to pull knowledge from it to further personalize your AI agents. And I would end this presentation by giving you a case study on how we are automating healthcare providers' patient interactions. So the goal is to streamline the administrative processes for these healthcare organizations and provide a seamless and accurate automation of frontline conversations and requests. Basically, patient conversations and requests that are coming through the different communication channels that I had mentioned. And some of the features that we enabled for this particular use case is that on onboarding of new patients through multiple different channels, answering any questions related to the services that are provided by this provider, scheduling appointments, guiding patients through the process that they're going to go through when they actually come on site to get their services, and also creating orders and management of these orders, including cancellation and reminders, and automating all of that. And lastly, one of the things that also we provide is handing off to the workload to the staff on site when it's needed. And the outcome that we wanted to highlight with this healthcare use case is that we were able to achieve like 70% automation of all the inbound requests. And we actually observed an increase in customer satisfaction score from below 70% to above 90%. And we were able to reduce the total resolution time by more than 100x. So if this is interested to you, please reach out. I'd be happy to provide a demo. If you email hello@stochastic.ai or reach out to me on LinkedIn by searching my name or the company name. Thank you for listening.
Thank you for presenting, Glenn. It was a really nice presentation.
Thank you.